And at that point, it's just
Yeah, I checked out that, by the way. I'm eavesdropping on it. If you haven't bought an Inspire, if you buy that CAS, which you'll notice instead of having a white face, has kind of a dark blue face. It actually, you can use it on an ACT now, and you can use it on the SAT, I think, but you can't use it on the ACT, which really doesn't make a ton of sense. Okay, let me say it again. You can use it on the AP tests and the SAT, but you can't use it on the ACT. And most people these days take the ACT. So I wouldn't get one. It is great. And it does some things like literally you could put a polynomial in there and say factor, and it will factor it. And like if I say solve, it can actually solve equations that have imaginary roots and write the roots out like square root of 3 over 2i or whatever. It can really do some great things, which is why the ACT doesn't allow it. But it's so they want to check to see if you can factor and if you can do certain things on the ACT. So they just banned it. But I mean, I don't know, whatever. So I don't know why they still are, because you could make a test where it's not going to help you that much. But anyway, it's your call if you haven't gotten one yet. At this point, we have covered everything. Doesn't mean it's floating around in your head perfectly. So I normally gave this for a homework. I would normally give it last night for homework on pre-cal if we were covering this in pre-cal, but I don't have to worry about them understanding how to use their calculator. So I did slow down a little bit. This is technically our classwork / homework. We're probably going to get finished with it tonight. Maybe the last couple things we don't get done, but we very likely may. We have a lot of question askers in my 5th period class, and we seem to have less people that ask questions in here. So it is highly likely that we'll get finished. But just make sure by the end of the day that you feel good about this. All right. So I'm going to have you walk through these problems with your calculator. This is your page, I think 129. Okay. So we're just going to walk through there. You'll notice on this first group of scores, they're not in order, which means that to be able to find the median and the quartiles and the modes, you would have to put it in order. Now you have a calculator. So if you have a calculator, there is a sort feature on there we've talked about. If you forgot it, I'm going to see if you can find it. Because honestly, I forget every year. And then I go, what am I trying to do? Oh, I can't figure this out. And most pads find their way through the menu. But I do want to see right now, can you type them in there? And can you calculate the stats on your own? Let's just see. If you have no clue, then don't get too far behind. At least get them in there. And if you don't even know how to get them in there, ask a friend right now. But make sure, because if you can't do this manually, you're going to be in a little trouble on your test. And then if you do it correctly, your mean should be 80.1. All right. So go ahead and enter them in there. And if you're correct, your mean will be 80.1. And if you don't get 80.1, I would love to use you as a guinea pig and ask you a couple questions. Because rarely, including last class, does everybody in the class get them in there correct. Getting close. Has anybody not gotten 80.1? Okay, I'm hearing less clicking, so I'm going to show you. If you have them in, I'll probably give them to you in order, so you're not going to have to worry about this. But if you don't have them in order, it's really hard without getting them in order to do all those other stats, right? I mean, you can, it's like, I mean, you can do still, you got Q1, median, Q3, they're given to you. But range, you're going to have to hunt down the high and the low. Mode's going to be tough. This thing's terrible in the mode category. Did you notice that? It had 1, 2, 3, 4, 5, 6, 7 different numbers that showed up twice. So there was no one true mode. It had 7 different modes, which makes it even a more useless statistic in this situation. But let me show you how to sort if you didn't know how to sort. So when I'm looking at this right here, I'm not trying to sort a single number. I'm trying to sort all of them. So what are all of them called? Scores. So what I do is I go up to score. And if I go up one more, it highlights the entire column. Which, by the way, if you ever wanted to delete the entire column without deleting each entry, you could do that. Go up there and hit delete, and the whole thing's gone. If I highlight the whole thing like this, now I can sort them. So where does most everything, all the action typically occurs through the menu? So if I click menu, and literally it's under actions, I can go to 1. And if I didn't know that, I could look under stats. But look at that, and I'm like, no, that doesn't look like I want to sort. So, but under actions, 1, you can see 6 is sort at the bottom. So you just click it. I want ascending from least to greatest. So hit enter, and it sorts it for you. Now it should be easy to kind of scroll through there and see where your modes are. You could write down the numbers that show up 2 or 3 times and finally settle in on what a mode is normally. Yes. Once again, I go up to score and then up one more. And when I got up, see, if you just move around, it's just one box highlighted. If you get up to there and do one more, it highlights the whole thing. All right. So those are your stats. That should help you with almost all of these stats, at least until you get to what? Outliers. So I can find the range by subtracting the high and the low. So I'm going to go ahead and write out what I have in here. Make sure that you're thinking and doing the same thing I did. So if you got, did anybody not get 80.1? That's pretty rare. Now, let me ask you this. Who went back? Raise your hand if you went back and double checked your entries. Okay, for those of you that did not double check, every year there are 1 or 2 people who enter them in badly and miss this. Every year. Most of the people get it right. So if you're like, okay, there were maybe 13 in here that didn't check, those are the ones that end up being wrong. The ones like, yeah, I didn't check, I should have. There's about a 2 in 13 chance of that happening to you. So 16%, you're probably safe. But if you're not, you just missed mean, you missed standard deviation. There's a chance if it landed on like a quartile, you're going to miss a quartile and the interquartile range and possibly the outliers. It can really snowball on you if you miss a score at getting it entered. The median is going to be off, because if you just leave a score off, then the quartiles end up lining up differently. Everything ends up being off, and you're just going to get crushed on a test like this. All right, don't let that happen. Okay, so anyway, 80.1, the mode, I had 76, 77, 78, 79, 82, 88, and 95. That's 7 numbers. That's a pretty worthless mode. The range, high minus low, was a 48. The Q1 was a 73. The median was a 79. The third quartile was a 91. The IQR is third quartile minus first quartile. That was an 18. If that's an 18, how do you determine outliers? You remember? Multiply that by 1.5. So I'm going to take the 18, multiply by 1.5. That gives me 27. Then that 27, you're going to do 2 things with it. You're going to add it to the third quartile, which gives me 118. Anything greater than 118 would be an outlier. And then you're going to do the same thing with the Q1, but subtract. So you're going to take the Q1, subtract the 27, which gives you what, 46? Anything lower than that, any score lower than that is also an outlier. And since there's nothing bigger than a 118 or smaller than a 46, then they have no outliers here. On your test, I can almost guarantee you'll have at least 1, because I want to see if you can do that accurately. But don't always think that you're going to be able to eyeball it. Like on this one, you can kind of, when you get them in order, you're like, you know what, they kind of start somewhere and they really just kind of move progressively through there. If you look at one, you're like, well, that's 20 higher. It's got to be an outlier. I have been known to put one that's 20 higher, and if it had just been 1 point more, it's an outlier, but it's 1 point under the cutoff. Okay, and somebody asked a good question. They said, what if the score is 118? Well, according to what I've seen in stats, it's greater than that. So a 118 isn't great. It would have to be a 119 to be greater than, or it'd have to be a 45 or less to be less than. All right, but that's what I know. And again, I don't have a stats doctorate or anything. I've just taken the class and I remember some stuff. And then standard deviation, I got 11.75. Ish. I was rounding. Now, somebody also asked, they said, you know, Mr. Hurry, when it comes to filling out that normal distribution curve, how many decimals do I need to use here? On your test, I'm going to give you the scores, but I'm going to tell you the mean and the standard deviation. Just use what I give you. And that way it'll be less tedious, because I'll probably only round to the tenths place. It'll be easier for you to write the numbers out and add and subtract. And then it'll be easier for you to do the other work. So like in a problem here on number 12, you'll see in a second, I'm going to use the actual stuff that I had here. You won't have to do that in a test. Plus, what if you do this wrongly? If I do this wrong and then I have to use it on my curve, I'm going to miss the curve too. So I give you a new set of data. I tell you the stuff this time, and that makes it a little easier on you. And then creating a box and whisker plot. This is probably the easiest one you've done, right? It says label the stuff right here. I'm labeling the outliers. There aren't any. I'm going with the low score, which ended up being a 49. So I'm going to put a dot on the 49. Remember, we don't draw box and whisker plots on a number line, above or below. In this case, you're going to have to go below. And then I need to mark the third quartile, median, and the first quartile. So Q1 was 73, but I'm going to mark that with like a little vertical line. So there was my low score, the 49. There's the Q1. The median was a 79. So I'm going to kind of eyeball that and mark that with like a vertical line. That's the median. The Q3 was a 91. So I'm going to mark that, ballpark it with a vertical line. And I'm going to put a horizontal line across the tops of those. And then the max was a 97. So I'm going to go out to 97, put the max, and I'm going to draw a whisker from the middle of that box out to the high and the low. Now work with me. What if in this situation, there was an outlier? So let's just say the outlier was 49. So if there is an outlier, what do? You put a dot on the 49. You take the next lowest score, right? Which would have been a 59. And then you draw the whisker out to it, right? And if there's more than one outlier, you do more than one dot. So make sure you do know how to graph with outliers, but that is not the case here. We did not have any, so we just have that line from there on. And then what does each part or section of this box and whisker plot represent? A fourth of the scores, or 25% of the scores. Just because it's longer doesn't mean there's more scores in there. Sometimes I've asked that as a trick question. I've said, which section has the most scores in it? And people go, oh, that right there because it's longer. No, they all essentially have the same number of scores, right? Because they're all 1/4 of the scores. This just shows that they're more spread out. All right. And then, so we're going to move on. So we're going to actually use the mean and the standard deviation above, but we're going to use those rounded versions. And but again, like I said on a test, I will give those to you to do the other stuff. All right, so I'm going to use that on this. So where does the mean go? Dead in the middle. And why is that? Because that's no standard deviations away from the mean. So I'm going to put the 80.1 there. Can somebody tell me what this I'm circling is? That's one standard deviation to the right. Does that have another name? That's a z-score. The z-score means how many standard deviations I am away from the mean, right? So if I ever calculate a z-score that's 1, it's right in the same place as one standard deviation from the right. Now, most of these curves are labeled with whole number z-scores or whole number standard deviations away, because that's what the calculator spits out as one standard deviation, right? Or it gives the length of 1. But anyway, that's essentially a z-score right there. So I'm going to add, I would do this on a test. I would say something like your average is 80.1. I would probably give you a set of scores, but I would give you the average and give you the standard deviation, which in this case ended up being, let's go with 11.75 even. But I'll probably round it to the whole number. So I mean, to the tenths. So I would give you something like that. And your job would be to just keep adding one standard deviation to the right, which is going to give you 91.85, 103.6, 115.35, 150. And then 127.10, and then going the other way. Be careful on this. Every year somebody gets a little off on this and misses this too. And I'm trying to give you an easy question here. And you're going to have your calculator, so there really is not a huge excuse for missing that. So now how can I use this, what I'm doing, right? is laying down my information from my scores above on a perfect normal curve. My information is not perfect because even if it was a good test, it's not that many scores. I had 30 scores here, right? So I want to see, does the normal curve predict based on what I have, what actually happened? So the first thing I'm going to look at is it says how many of the scores above showed up between the -1 and the +1 standard deviations, or z-scores of -1 and 1. So I'm asking how many scores ended up being greater than this right here, greater than that -1, but less than that. How many scores? Okay, so if I want to figure out how many scores are in between those two, I look at my list and I start counting. Now there's a bunch. Anybody get it? I counted 18. So I'm looking, what's bigger than a 68.35? So I look at my list and I go, well, there was a 70 and there's a bunch of scores, and I'm going to go all the way up to less than a 91.85. So basically all the way through 91. And if I count all those, I get 18 scores. Now, if you remember from yesterday I said what percent actually showed up. So if I'd asked that, then do 18 divided by 30, whatever that spits out, 0.6. Percent or whatever, 60%. But I just said how many. So 18 were actually in between there. Now, what did the normal curve predict would be there? What did it predict? Didn't it predict that percent? So if it predicted that percent of the scores, let's figure out what that is. So I'm going to take, and this is in part A, I'm going to take 68.13%, which is 68.26%, which is 0.6826. I'm going to multiply that by the number of scores. And that spits out about 20, I think, was it 0.48? So that means 28.48 students is what the normal curve would have predicted. Is that accurate based on what actually happened? No. Now that rounds down to 20. So I would say 20, but it's so close. If I had gotten 20 or 21, I would have thought, wow. But does it surprise me that it's not accurate? Not at all. I only had 30 scores. I am not going to get a perfectly nice prediction every time when I have a small number of scores like this, or even if I have a big number, it's not going to be perfect. And then how many scores showed up between the average and the +4 standard deviation? If you add all those up, it adds to 50 because that's half. In real life, it's more like 49.9997 or something like that. But it's pretty close to 50, right? If I'm just using this information. So 50% of the scores should have been what? Down here? I'm jumping to part B. 50% of my 30, I should get 15 scores, right? But if I count how many scores actually ended up being between an 80.1 right there, how many were greater than that? Just greater than that. You start counting, anybody? 13 is what I got. So 13 scores showed up there. It predicted half, 15. Is that accurate? No. When it says why not, you could say 13 is not equal to 15, I guess. But the real why, I just didn't want to see no. I wanted you to kind of show that no right there, because I actually did this. No, it's not accurate because it should have been 20.48. But if you just said 18 is not 20, 13 is not 15, I can tell that you've actually done the math. Y'all seeing this? And then on the back side, we get into some more different calculator use. Remember, if you have your own calculator, guys, you could leave this equation in there. Once you get it in there and you get your screen set up, leave it in there and it'll be ready to go on test day. It's not about can you type this in your calculator. I mean, it is a little bit, but if you own your own calculator, great. If you're borrowing one of mine, you could just hope nobody erases your equation. Might happen in another class. I know my AP Cal kids, most of them have their own calculator, but in my pre-cal kids, it's possible they need it for something. But if you just remember the calculator number you have, it's a good chance it'll still be in there, right? But I want to make sure you know how to use your calculator to actually find percentiles or area under the curve. So if you're reading this, it says graph that equation. So I'm going to get away from the screen and show you what I'm doing here if you don't know how. So I'm going to go ahead and graph the equation. So to do this, I really don't need this screen anymore. If you want to save it, you can. I'm not going to. So I'm going to exit out. And do I want to save? No. Okay. So I do want to graph something though. But if you did want to save it, then just go and just jump to my calculator button and it'll give you a graph screen. Now, I don't like this window or even a standard window. A normal curve looks really great from -4 to 4, which is usually by the time it hits the x-axis or gets really close. And then it actually only goes up to about 0.5. So what I'm going to do even before I graph it, listen, if all I do is graph it, look, I'm going to go fraction button, 1 on the top, the square root of 2 pi e function. That's the e function right here. Don't use letter e. There's a difference. Letter e is an undefined variable. E function, the calculator know it's 2.71828, blah, blah, blah. So I'm going to do e function to the x squared. And when you see that, you just see this kind of a weak looking bell curve. It's okay, but I'm going to change my window. So if you forgot how to change your window, check it out. Again, almost everything goes through menu. So I'm going to click on menu and I'm going to choose window, which is 4, and then window settings. Okay. I'm going to go out from -4 on the x-axis, tab to +4, scaled at 1. Scale at 1 means it puts a tick mark every 1, which is kind of what I like to see. All right. Then I'm going to go to the Y. How low do I want to go? I can put 0 if I want because I don't need to see below the x-axis. I like to go -0.1 though. I like to kind of see the x-axis clearly. And then I only need to go up to about 1/2. So 0.5. And I scale that at 1 also because I don't like to see tick marks on the x-axis. If you have auto, it's going to put a bunch of extra tick marks. And look, it gives me a nice, clean looking bell curve. Usually puts the equation for me down at the bottom left. I don't know what it does for you. If that's bothering you, put your cursor over it, close it, and drag it up somewhere else. So like if you wanted to, you could come down here and put your hand on it, click to grab it, bring it up where it doesn't bother you if that's important to you. Yeah. You have a question? Now, let's read through this question again and see what it's saying. So the question on whatever number that is, 15-ish or whatever, says, it gives you the setup on the window if you want. I said 0 to 0.6, but I honestly like 0.5 better. It says calculate the percent of scores in a standard normal distribution that should be between a -1.5 and +1.5 standard deviations from the mean. That's the same thing as saying between a -1.5 and a +1.5 z-score. Now, does anybody remember what is the area below this curve? 1. So that's the reason why it doesn't spit out 68%, right? Now you could kind of fix that by changing your function to times 100. And if you made it go up by 100, I'm pretty sure it would change. Actually, I don't know that it would do that. It might actually work, but forget it. Just remember that when you find area, it's going to give you a decimal part of 1. So move the decimal twice, and that's the percentage. So if I want to find the area from the -1.5 standard deviation, which is right here, right, and the +1.5, which is right there, I'm going to actually use calculus to integrate that function because integrating gives you the area between the curve and the x-axis. So all I have to do, super easy, but you got to know how to do it. It's only a calculator question, is to go menu, and you're going to analyze the graph by taking the integral. So if you hit the menu, hit 6, and I think for most calculators, it's 6 again. For some really old ones, it might be 5. because they added something else in there, but 6, 6, and it says, hey, what would you like your lower bound to be? Guys, you're never going to eyeball 1.5. You're not. So just type in negative 1.5 and hit enter, and you'll see the word lower bound suddenly switch to upper bound. Now, if your calculator, if your hand is somewhere else, it's going to give you whatever area it is. So don't write that down yet because you haven't put the upper bound in, right? Still question mark. So then enter 1.5, enter again, and it spits out the decimal part of 1. So if that's 0.86639 of 1, that's 86.64%. Now, if you're looking at this number right there and you're not seeing at least 4 decimals, you're not going to be accurate to the hundredths when you move your decimal. Okay? So right there, if you're seeing 0.87, when you move the decimal, you're going to write 87 down, but the answer is 86.64. So does everybody know how to change that decimal thing? Good. If you don't, remember, if in doubt, what are you going through? Menu. You hit menu, change your settings. I love fix 5. Of all, fix 4 might be okay, but fix 5 has always done me well. So fix 5 gives me plenty of decimals for anything that I possibly need in calculus, algebra 2, pre-cal. If you are on float, you are living in a bad world because float is like a significant digit and it's going to float around and give you the first 3 numbers in your number, which sometimes throws off all the other important ones. You do not want float. At the very minimum, fix 4, but I like fix 5. You just hit and make sure you're in radians for now, but I guess it doesn't matter for the work we're doing. Hit enter, and you'll see those decimals again. Now, by the way, if you're going to be doing more work with this, you might be bugged by the fact that you have that shaded right now. Once you get whatever you need out of there, just hit Control Escape. That's you'll have a back arrow on yours. Control Escape gets rid of that. And you don't have to look at it anymore. Now, if you've already done another calculation and you've done some other junk and it's too many going back to erase it all, you can always highlight the number, like click on the number and highlight it and delete it, and the shading will go away that way too. But you'll probably have a bunch of points on the x-axis. But it doesn't matter. All right? So 86.639 or 64 or whatever. Now, question 16a. Question 16a says, how many z-scores would a score of 98? Does yours say that? How many z-scores? It doesn't? Okay, I changed that after I printed yours. The key even says how many standard deviations. But when you figure out how many standard deviations away a score of 98 is, that's a z-score. So change it to read how many z-scores, which is the same as how many standard deviations would a score of 98 be away. So I'm essentially saying, what's the z-score of 98? Because I shouldn't have written how many. I should have said, just determine the z-score. But that's the z-score tells you how many standard deviations you are away from the mean. Now, do y'all remember how to calculate a z-score? So you take the what? The score that's in question. You find the total distance away from the mean, right? So you subtract the mean. And then you go back. Now that you have that total distance, you divide it by standard deviation to see how many times standard deviation goes into it. And that tells you how many standard deviations you are. Now, on my key, I think I used the exact standard deviation, which was like 11.7511, blah, blah, blah. I'm going to be giving, and you should do that, but I'm going to be giving that to you on a test. So for our work today, let's just use what we've been using. And if I do that, 98 minus 80.1 divided by 11.75 period is 1.523. So even on my key, it says 1.523, but in real life on my key, I used the exact value. So that was a little bit off here, and it actually slightly affected the percentiles a tiny bit. But again, that won't be a problem on your test because I'm giving you those two things. Now, the question is, now that I know how many z-scores away it is, can you figure out the percentile? Well, remember, a 98, that means this, essentially. You have this bell curve, right? And there's the average. the 80, what, 80.1. This score of a 95 was about 1.523 standard deviations away. So what's a percentile? Percentile is saying what? What percent of the scores based on this curve are you better than? So it wants to know what's the area to the left of that. Well, if you look at my key, I used to do this. I used to say, well, if I want to find area, what's my left bound? Remember, -4 is just a rounded value. It's about 50. I'd really want to go out to negative infinity. So what I used to do to be really exact is I said this. I said, well, what you want to do to find the percentile, I would say, go ahead and take 50 even. 50 even is this part. And then you could use your calculator to find the area between 80.1 and 1.523. Or I'm sorry, between basically a 0, z-score, that's a 0 right there, 0 standard deviations, and 1.523. So I used to do that. And if you go to your calculator and calculate that, and I'll show you in a second, it spits out 43.61-ish. Okay? And then I would say, now just add those together. So 93.61 would be my percentile. Right? Now, watch. If I do this actually on my calculator, check it out. I could go in there and go menu, analyze the graph, integral, enter in a 0 for the mean because you're 0 standard deviations away. That's a z-score of 0. And then enter in your, what was it, 1.523. And if I do that, look at 0.4361. It gives me the same thing I had before, right? But watch this. If I go ahead and go menu, analyze the integral, and instead of picking -4, which is close, I just pick a random number like -8 or -10, which is way to the left. In fact, you'll see so far to the left, the decimal part of the area that's below the curve there is so small, it will never show up when you round to the hundreds. It might show up if you round to 10 decimal places, but I'm not going to ask you that. So if I go way to the -10 and then go to 1.523, look, you'll see the score is exactly right out to any decimal that we're interested in. So I don't do this way any longer right here where I go 50 plus that. All right. I wouldn't even bother. Just when, and you can see right here, I think it's pretty clear that out here at -10 z-score or -10 standard deviations away, how much area are you really accumulating on these intervals? Very little. But out there at -4, it's like, let's just try -4 if I did it. You might still be okay, but I'm going to play it safe. If I went from -4 to 1.523, look, I'm off. 0.93609. Actually, you would have been okay. Because look, if I round, sorry, you can't see that. If I round that to the hundredths, I get 93.61. If I round that to the hundredths, 93.61. So you were still lucky that it rounded nicely, right? But you can see the numbers are a little different when I only go to 0.4. But they're so, anything like -8 or -10 is going to be perfect for you guys. Y'all seeing that? So one more time, I'm going to get rid of this stuff. And let's just walk through that next one. So has somebody done it yet? How many standard deviations, or what's the z-score of a score of 35? Has anybody done it? -3.83. So just round it. Let's round it to -3.838. Okay. So if it's -3.838, going down to the next one, what percentile would that be? Now that's pretty low, isn't it? -3.8 is pretty close to -4. And there is very little area beyond that. So I'm guessing I'm in a pretty crappy percentile here, aren't I? But if I'm going to calculate that, I'm going to go, all right, menu, analyze the integral. I'm going to go with -10. Just why not? And then I'm going to go with negative 3.838. And you're going to see, look, I can't even see that area, but you can see it. So if I was going to write that percent, what would I write? I'd move the decimal 2 spots, and I'd say 0.006%. Or if I'm rounding to the hundredths, I guess I could say 0.01%. So, and I think it's pretty clear if you made a 35 on this test that you were pretty bad, right? You were way below the low score, which was already pretty bad. It makes sense that you're pretty near the 0. And then if you've moved on, what's the standard deviation or what's the z-score on 120? Anybody get that yet? 3.395. So if you had a 3.395, I could find out its percentile once again by going menu, analyze the integral, -10 lower bound, 3.395 upper bound, and it's going to be really close. I mean, 4 standard deviations, almost 100, almost all of it. Again, it'd never be the 90 at the 100th percentile, but on this one, if you were rounding, that would be the 99.97, I guess. If you were rounding to the 100th spot after moving your decimal. And I just write percent with an aisle on it to show percentile. It's a little quicker, but what do you think? That's about as good as a crash course in statistics as you can get in 3 or 4 days. That Algebra 2 textbook stretched that out and didn't even cover percentiles. Didn't cover a lot of things, and they did it over 4 chapters. So I think we're in decent shape. Well, all we're doing tomorrow is reviewing. There are some good questions on that review sheet that maybe don't show up on a test. Also, somebody made a comment about on the assignment sheet, how I mentioned something about regression. That was, I copied and pasted what I did for pre-cal in, and we cover regression with statistics. We're not doing that, so I just forgot to delete that. So this is a pure statistics chapter. That's it. And by the way, if you, again, I'll put a plug in. If you haven't had plans to take stats, it's a pretty good thing, especially if you're thinking in your head, yeah, I'm going to graduate school. I want to get a doctorate. You're probably going to have to do a little research, show you results. Anything you can do in stats to help that process will make your life a lot easier. It's pretty interesting, and it's actually a pretty easy course for people like you guys. Yeah.
So does the actual review start here? This looks like
That's what regression is. Oh crap, I did. Okay, I did. Oh no, I printed you off a new one. Yeah, it's not due until tomorrow, but I can give it to you now. Yeah, I didn't realize that until later, so I did make a new one. This is the review I want you to do. If you did the other one, you don't have to redo it because it's the same stuff, and that's fine. You can turn that one in, but if you haven't done it, get rid of that. Get rid of the review that you have in there and replace it with this one. Yeah, thanks for saying that. And this one, again, the first time I do anything in a class, there's going to be little omissions that I have. But anyway, I think that this review, and it's really not that long. It's pretty similar to what we just did. But anyway. All right. Hopefully this will be a good test for you guys. I try to get a couple of easier tests in there after trig identities. Trig identities takes a bite sometimes with some people, but hopefully we're doing that. Oh, I got a couple of questions. Yeah, I have time. Who in here is an AP Chem? 2 of y'all currently? 2 of y'all? Trying to figure out how to plan Who is in here taking AP Psych? AP Psych? 2 of y'all? So those are the only 2 afternoon AP exams that you guys would be taking, I think. Okay, so that's not a ton of a conflict. So you guys that I just mentioned won't be here on either Monday or Tuesday of next week. So if you can, now that's going to wipe out. Do y'all know anybody in 5th period who's taking AP Chem? Just your brother? Do you know anybody in 5th taking AP Psych? Marion and Ann, anybody else do you know?
Evelyn.
I forgot to ask them. So not a ton of y'all. So if you can remind somebody, you won't be reminding them from the exam because you'll not have your phone. But if you can get somebody to remind me to start recording, I'll do it. Like it's recording now for Finn. But if you don't remind me, I'm not going to remember, even if you write something on the board. I mean, I might, but it would be shocking that I would remember. Too many things are running through my brain at every moment of the day that I think about those things. So even though I have an alarm on my phone, it'll say, start the video. I'll still forget. I know my weaknesses. Yeah, and like I said, if you can get somebody, I can try to record it, or you can hop in if you're, that's of next week, right? This week you'll only miss Friday. Okay. So I'm probably gonna. You'll definitely miss some. But there are videos to be recorded. And I really like probability. I haven't figured out exactly what I'm covering with you guys. Because we normally don't have to insert a 5-6 day stats unit. We'll figure it out. You may be the last math team algebra 2 to ever get a good lesson in probability. Because it took me years to figure out what I know, and it's.
Oh, Crenshaw will miss it too. I didn't know that.
Anybody else in track in here?
Not
Anybody in another class? Really?
in our grade,
Nice. All right.
Did you did?
Hey man, I'm going. Yeah.
You look so much older than you did. That's weird. Well, I don't know about Spanish.
30 at best. And you know what? I got better than I thought, but it's still not a good grade.
Improvement.
I was up way too late last night studying for it. Then I ended up paying off. Which means that just going to reinforce my behavior.
Where you said, Carl, you said?
I said kids look older back in the day.
I said that right before you walked in. I said exactly.
I think it's because like we see people like in the 90s and they're gonna have like clothes and hairstyles we associate with people who were teens in the 90s who are like adults now.
Yeah, you can just do. That's all the band. Hey, right here. It's not.
It's like 32. Like this man works at like he works at like a warehouse in like Irondale.
You got it, right?
It's like over 7 years.
You probably know exactly what I'm talking about.
Now, hold on. I gotta see. Who y'all pointing at?
The guy with the goatee.
Who y'all pointing at? Looks like you fixed the word.
Yeah, it's 35 years old.
We just, that's funny, is I have literally no memory of a conversation with him. But still keep in touch with him. Still keep in touch with him. Still keep in touch with her, sort of. Still keep in touch with him. Those two are on my Instagram page, but they're completely different.
Got my brother's.
There's a ton of my stuff keep in touch with guys.
That's great.
That's
I think it's a big, you know the Perlises? You know Charles Perlis, realtor? In town? It's him. Or a Stephen Perlis?
Do you think it's special?
This guy pulled a great prank on me once. Can I tell you this? A Sprite can. So I had this Sprite can. Somebody gave me this Sprite, put it on a shelf. I totally forgot about it. Got buried in the back of this bookshelf. I found it, looked at it. It had expired like 7 years prior. It literally had been in my room for 10 years. Or maybe it was almost expired then, whatever. So I had this Sprite, and it was sitting in a koozie. Well, one day he comes in there and he goes, "Hey man, can I have that Sprite?" And I was like, "No, it's expired. You don't want it." He goes, come on, let me have it. And I was like, "You can't have my Sprite can." He goes, "Come on, I want your Sprite." And I'm like, "Dude, it's expired by like 8 years. You're not gonna get this Sprite." I said, but anyway, he goes, "I'm gonna drink it." I'm like, "If you drink it, I'm writing you up for defiance of school." And I love this kid, but he was like lunch study. He would come in then. So every day he would come in during lunch study and pick up this Sprite can and go, "Can I drink your Sprite?" And I'm not kidding. Every day for probably 6 months, he would come in. And I mean, it was the same thing. He would come in, he'd pick up the Sprite can. And he would just mess with me. And I looked at him, I was like, "Dude, you do?" And I'm writing it. One day he comes in, because I drink the Sprite. Like he'd always, and then he goes, and he had this crazy look at us. And I went, "He did not just open that." He goes, and starts drinking it, and I'm like, "You're going down." So I reached for it and I grabbed the thing to. I don't even have a form to write anybody up. Like I haven't done it in 12 years. Whatever. I don't even have one. I'm like, I literally would not even know what to do other than to go, "Get out of my way." And I reached for it and the class busted out laughing. He had switched the Sprite cans. And I was like, "Okay, you got it." And anyway, so he lives in Homewood. I see his brother more around, like I see his brother Johnny's, whatever. And then out of nowhere, this fall, I took a day off because my sister, first time in 18 years, she's come to see me. She has 6 kids. It's hard to track. And I see her all that time when I fly out there. But she came and I was like, "No, I'm going to take a day off and I'll go downtown, show them the downtown area." It was a beautiful day, whatever. So I go down there and I'll go into, what's Red Cat or something down there by Redwell Park.
Oh, yeah.
And I get a little coffee with my sister, a little frappuccino or something or other. And I come back out and my brother-in-law and my wife and them were like, "We were just confused with models." I'm like, "What are you talking about?" Because somebody walked up and went, "Are y'all the models?" And they were all full of themselves. And I was like, "Well, the model was Charles Perlis." The dude hasn't aged in 20 years. He looks exactly the same, still really good looking guy, thin, in shape. And I don't know, he's probably 38 now, 37, 4 kids. But he's a realtor. If you ever see Perlis Realty or Charles Perlis Realty, that's who he is. And he knew he wanted to be a realtor when he was 16 because his dad was. He goes, "I'm going to be a realtor like my dad." And he is. Anyway, he does modeling on the side or whatever. So, but I ran into him. He goes, "Mr. Carter, did you remember me?" I'm like, "Of course." Like, "But Sprite can."
That's great. You probably got stories about that, like on every single class photo.
Maybe. Sometimes it was kind of a class that didn't impact me. No, like maybe my 4th period that just doesn't want to talk or whatever. But even those guys, some of my top 3 years, I can tell stories about them. You know, like I have a relationship, they're just quiet in this particular class for some odd reason.
Just the dynamic.
The dynamics just aren't, there's nobody to kind of spearhead the effort. Like in your class, there's a couple people, like there's a Hudson,
Oh, yeah.
you know, Todd get things going, or
That's us,
you know, but anyway, there's a couple little people that bring some, and it just it snowballs and it cascades to the other people and it makes it.
Our class is really fun.
But fourth period,
Henry and Will are.
Nobody
right
wants to
now. I'll tell them. I'm gonna tell them that.
they'll know it.
Oh no, they know it.
Yeah,
They're like Mr.
they're all
Rogers are
really
quiet.
sweet people, but they're just too freaking quiet. They just won't let me have fun.
Will and I were talking about our class last year, how we had like 7 people, and
Yeah,
we
it's
were
like this seventh period.
Yeah, we were like it was just so sad. It's so quiet. Nobody talks.
They're worse than that period.
They are.
Oh yeah.
Oh my god, that's bad.
Oh, it's bad because at least you would say some things occasionally, and
Yeah.
Natalie and Clara every now and then would get irritated about something and speak up.
No, she would ask, when are we ever gonna use this in the
Right.
world?
And she loved my answer.
She did, yeah.
But the point is, it's worse than that by a long margin.
Oh, that's terrible.
I don't know what it is. And again, there's fun, really sweet people in there. It's not like I hate them. I mean,
It's just quiet.
for some teachers, it would be a dream class. Hey, I can sit up here and lecture and nobody bothers me. But for me, I live in a conversation. I teach with questions. And it's just painful when you answer your own questions. I mean, there are times when I would go, right. And nobody would have said anything.
So when do we get the exam review?
Carson, I have actually went last night because of you, updated it, put the new exam schedule, changed the dates or whatever, changed the content that has changed, and I printed it. It is heading towards the printer.
It's on.
But when that will happen, we will see.
I gotta leave at 2:45.
All right, so guys, here's what we're doing today. Today, I'm going to talk about how we can actually use our calculator a little bit. I believe it's page 105, but you will need your Inspire. I'm going to show you, because the AP test, about 1/3 of it is calculator driven. All right, there are going to be 2 of the 6 free response questions and 15 of the 45 calculator. Now, even of the 15 that are calculator questions, you might not need a calculator. Oddly, it's just on the calculator section, but about 1/3 of it. I know it says 37%, but things have changed a little bit. It's more like 33 now. Okay, so there are 4 things that they need you to be able to do with your calculator. The first one is graph a function. I think we can already do that now, but some people don't have access. That's something you need to do. Second thing is you need to be able to solve an equation, any equation, by graphing. I've talked about that. We'll talk about that again. The third thing is calculate a numerical derivative. It cannot actually calculate the derivative, but it can graph the derivative function, and it can tell you what the derivative value is at a certain x value, like at x equals 3. That's a huge feature on this calculator, and some people don't use it because they're still trying to do everything manually. And the last thing, calculate a numerical integral. You guys actually did that sort of when we did stats, when you found the area between 2 things, but there's actually a button that calculates an integral of a function, and you could do it that way too. The area, and we say area under loosely, it's the area between the curve and the x-axis. Technically, the area under the curve would be infinite, but the area to the x-axis. And there's different area, like if the curve was above, that area could actually show up positive or negative depending on which way I drive the integral. If I go from 0 to 4, integrating and adding to the right, it would be a positive area above. If I go integrate from 4 to 0, it would be a negative area. That's for another day, but not for what we're talking about today. Anyway, I want to give you some examples of how we use it. So hopefully you have your calculator out. This says, for the given function y equals, calculate the derivative of the y with respect to x at the x value of 4. Now, just imagine you didn't have a calculator. For you to do that manually, you would have to calculate the derivative of this 3-part product rule. So we've done those as a bonus. You would have to take the derivative of the first times the second and the third, plus the derivative of the second times the first and the third, plus the derivative of the third times the first and the second. And as you were taking the derivative of things like the second or the third, you've got a big chain rule involved in that as well. Then you would have to take those 3 different parts and plug a 4 everywhere you see an X. Hopefully, if you did all that right and did all your and typed it in your calculator or whatever and simplified, you would get your answer. But with the calculator, it's really easy. Now, there are things that I do with my calculator. So I'm going to jump screen here so you can see this, that I have started to get into a habit of doing that makes my life easy. So for one, let me just show you what you have to do and then what you could do. So here's my calculator. I'm going to delete all that junk because I don't need it. And I'm going to go to my calculate screen. Now, if I wanted to, I could get a DDX on the screen. You can kind of see the DDXs I have right here. And I could start the process of entering my function. That's totally fine. You could do that. You'll have a little place already that you'll see where the 4 was taken, and it would spit out your answer. But usually on an AP test, they're asking more than just a derivative. What they're usually saying is something like this. Find the equation of a line tangent to this function at x equal 4. Well, if I asked you that, what 2 things do you need to find an equation of a line tangent to a curve? A slope and a point. So you're going to need to find the derivative at 4. That's for certain. But then you're going to have to do what to get the point? So it sounds like I'm going to have to type this equation in twice, aren't I? I don't want to type it in twice. So here's how to get away with typing it in twice. And even when you only need it once, when you have built this into your habits, I think it ends up being productive. So here's what I do. I go and I graph it. And it doesn't even matter what the graph looks like, because once I type it in, that graph has a name, F1. And from here on out, all I have to do is take the derivative of F1, find the value of f of 4, and I can use f of whatever for all my other applications, and the equation only has to go in once. So watch what I'm going to do. I'm going to go tab, and I'm going to type in this equation. All right, so here we go. 3x times the sine of e. And by the way, when you use the e function, don't use letter e. Letter e is a random variable that has not been assigned a value. I want to use the value of e that's 2.7182818, whatever. So use function e to make sure that that e has a actual value to the 2x, right? And then I'm going to go times the natural log of 4x minus 3. And I'm going to graph it. I could care less what the graph looks like, although you'll see it's a disaster. And you can only imagine that the slopes on that, since it zigzags up and down so many times, is probably pretty steep at x equal 4. So who cares what it looks like? I'm now going to get off this screen and go back to where I'm going to do business. Now, I want to take the derivative here. And if in doubt, where do you find most stuff? Under the menu. I'm always going to the menu to analyze the graph. I'm going to the menu to do other things too. Okay? Yes?
Do I need to change that window?
I don't even care about seeing it. You can change it if you want to. But I literally, guys, I am doing this, so you'll see in a second. So from here on out, I can just use F1 anytime I need to do something. I can do F1. And I don't have to keep typing in this equation. Otherwise, this would be my problem. See, I can now go to menu where almost everything occurs and go to calculus 4. And under calculus, you'll see numerical derivative at a point. You'll also see numerical integral, which is what I do if I ever need to integrate. But that's for another day also. So I'm going to hit 1. And it goes, well, what variable do you want to use? Well, we're doing f and x, right? So I'm going to use x. And I'm going to go down or tab. So at what value do you want to integrate? Well, it said x equal 4, right? So I enter the number 4. And it is, we want to take the first derivative, right? So I'm just going to hit enter. And it sets up the format for me. ddx of what? From x to 4. Now, if I didn't have my calculator, my equation already graphed, then I would have to type my equation in right there, which is not a big deal. If this was the only thing I had to do, I would probably I could type it in there and I'd be fine. But the fact that I've already typed it in there, all I have to do is go vars. Your var button is above 9. Hit my var button and go down and choose F1 because that's where my function was entered. F1 of what? F1 of x. And it's going to calculate the derivative of the equation that I just had at x equal 4. And bam, it spits out. Now it's a pretty steep slope, negative 168,038, right? But that's just because I picked a weird equation. Now here's how doing it my way would be helpful. What if we were actually trying to find the equation of a line tangent to the curve? How are you going to find the y value of the point at 4? So you're going to have to go back now and go back to your equation, and you're going to have to type in, all right, I got to go 3 times 4 times the sine of e to the 8th times the natural log of 13 equals, right? Because you're going to have to enter 4 into your equation. Are you following me? Guess what I have to do? Y of 4. Done. Because I've already got my equation in it. Are you seeing how helpful that is? Now, again, if you don't want to do that and you want to go, no, I'm stubborn. I like doing it the hard way. I could go 3, enter the 4 in for x, times the sine of e, enter the 4 in to the 8th, times the natural log of 16 minus 3 is 13. I'm going to get the same thing, right? But I just spent an extra 20 seconds typing that in and 20 seconds with every single problem. And if you have to do that 15 times, you're out 7.5 minutes. You might not even get to the last couple questions. And you're out 2 or 3 points because you were stubborn and not efficient. So be aware of what you're doing. Sometimes the problem, you're using the same function 3 or 4 times. So having it in there and then just using its value is great. Look at example 2. Calculate the second derivative. Oh, crap. Now I got to go through the process again, right? I got to go menu, calculate the numerical derivative, x. At this time it says at 1. I got to go down there and look. It has the choice of now calculating the second derivative. And look, it gives you a nice setup for you. But if I didn't have my function already in there, what would you be doing again? Typing that function in again. What am I going to do? Well, vars f1 of x. And it's going to spit out my second derivative. So I'm telling you, on most AP Cal questions, you are typically using a function more than once. So if you're ever calculating, and listen, how much extra time did it take me? I went graph screen, tab, and I typed it in, right? That's 2 button pushes. And it saved me all that other misery. And then right here, I didn't even have to type it in. I had to do maybe 2 or more button pushes. So to me, it's saving some time. And in the long run, I think it's saving a lot of time. If on the examples I was just giving, you would have had to type the function in 3 times. Once for the point, once for the slope, once for the second derivative.
Wait,
That's 2 more times you need to.
when you're storing, you click Control bar, and then you click whatever variable.
I'm storing something?
Yeah, like you store it as F1, or you assigned it.
No, I didn't. No, I did this. I went and graphed it. I graphed F1.
Oh, and then it just holds it.
Yeah, and as long as it's sitting there, that's your F1. Now, if I delete that, then there's nothing in there for F1 anymore. But that is my F1 as long as I want it in there. No, I can't store it like that. Now, if I wanted to do something like, say I was back here and I typed in something like, I'm just going to make something up, like sine of 3x minus 4 times e to the x. If I hit enter, it's going to go error, right? It's not going to be able to do anything like that. So it can't do that. Anyway, so don't.
Why can the calculator spit out a numerical derivative at a point and not like the general derivative?
I don't know. Because it's essentially probably because it's graphing it and finding the y value there.
I'm getting it.
I'm finding the slope of the y value. Sorry? Oh, yeah. If you're in degrees, it's not going to do it. Because anytime you have a trig function, you got to be in radians in calculus. I haven't said that, but that's remember, degrees are arbitrary, guys. It's a man-made number. It's a man-made idea. A radian is a measure of the angle by choosing the radius. It's measuring it like that angle. If it's one length of the radius, that's 1 radian. If it's 2 lengths of the radius, it's 2 radians. So it's nothing manufactured or made up. So AP Cal, you will only use radians. Only.
How does that apply to this though? How does like?
Well, if I'm in degree mode, anything that goes into an angle, right? So when I take a derivative, I'm taking slopes. You can actually take derivatives with degrees, but you literally have to do a conversion factor every time you do it. Do you want to do a conversion? I don't. So most calculus teachers don't even teach that. And AP has no degrees on the test unless they're talking about temperature. And they do Newton's law of cooling or something like that, exponential growth with temperature or whatever, or cooling. But nothing, every angle will be a radian. Guaranteed. All right. All right, so flip that page over. Guys, flip that page. Everybody good on this so far?
Yeah.
Okay, so flip the page over. The question was, it gave you a function. I'm going to get off of this for a second. Okay, so I'm on that next page, example 3. For that given function, I don't know what that looks like, y equals whatever, determine when the derivative of f is equal to 10. Now, one way to do that is to go, well, they're literally saying, when is the derivative of that equal 10? Now, some people go, well, I guess I need to take the derivative. And they'll go first d second plus second d first, and they'll write that out, right? And then set it equal to 10. Well, guess what? When you do that, you're going to have an ln of something x. You're going to have an x. Do you think that you can solve an equation with an ln of x and an x in there? I can't. I'm not sure you can either. Okay? But what I can do is solve an equation. And here's the thing. I'm not even going to take the derivative. My calculator can graph a derivative. Okay? So if you want to graph the equation and then do this, you can. I'll show you that as well. But literally, and I'm going to use option 2. I don't like option 1 as much. Literally, I'm going to type in my calculator y equals, when I graph it, or F1, I'm going to type in y equals the derivative minus 10. Because if I have this statement, the derivative is 10, if I subtract that 10 to the other side, I have this. I'm going to replace the 0 with a y. That's y equals, or F1 of x equals this. I'm going to graph that. I'm going to let my calculator do the work on the derivative. And then anywhere that graph crosses the x-axis is where this is true. That would be the x values. And the question is, determine when the derivative of x on that interval. So I want to know the x values from 0 to 10. Does that making sense? Now, if you want, you could do this. You could, instead of doing what I'm doing right here, you could graph F1 as that function there, 3x ln 4x minus 3, right? And then down here, you could just do d dx of F1 minus 10, and then you could graph that as well. It would be in red if it's the second graph. I'll do it that way. And then when I graph that derivative, that way I'd have the function in there if I ever need it again, right? Like we've been talking about, but you would be graphing the derivative of that. So let's just say we did it that way. Check it out. And because they told me from 0 to 10, hold on, I don't want to do that. Because they told me, I don't want to do that either. Hold on. Okay, this is what I want to do. So check it out. I'm going to go back to my calculator. I'm going to delete, delete, delete. If you click delete 3 times in a if you click delete 3 times, it will let you erase everything all at once. So watch. I'm going to go to my menu. I'm going to change my window settings from 0 to 10 because why would I care about seeing anything other than that? So 0 to 10, and I went up and down to -7 to 7. So here's what I'm going to do. Tab. I'm going to go ahead and type in the function for f of x. So 3x times ln of 4x minus 3. So there is my function. There's my function, okay? Now, then I'm going to graph, again, for F2, the derivative function. Now, here's the thing. Look what happened. Oh, you can't see that. Sorry. So there's my, I'll go up there and show you. There's my F1. I typed it in and you can see it. Now, for F2, check it out. For F2, I want to graph the derivative. Now, look. When I hit menu, there is no sign of calculus anymore, is there? Is there? Because they don't want you to calculate a numerical derivative. But I still want to graph the derivative. So look, they place the derivative also on the left side of your book key, right there. So click the left side and look what options you have. DDX. So I'm going to click that and it will throw it in there. And the great part, it doesn't have that bar with the x equals because you don't want to calculate derivative at x equal 4, x equal 1. You want to graph the derivative. So now I can go DDX and look, I can insert my F1 so that I'm taking the derivative of F1 of x. And then I can come outside, remember, because we're subtracting 10 from it. So literally, this is me doing what I was doing in your book on option 2 in that second step. I'm graphing the derivative of the function minus 10. And anywhere this thing crosses is going to be a place where the derivative equals 10. Are y'all seeing that?
Crosses at 0, crosses the original function.
Any 0 on this
0.
will be where the derivative graph was equal to 10 because I moved the 10 over, right, and graph that instead. All right, so right here, all I got to do is go menu, analyze the graph, the 0, go up there, and I got to pick the right graph, right? So I grab the red one or whatever one that is, and look, I can go left bound. So I go to the left, click, and as I start moving to the right, there's the first point. You see it? It's kind of hard to see, but it's right there, 1.155. And if I just keep scrolling to the right, the second point shows up, which is nice, 2.375. Y'all seeing that?
Wait, are those the values that the derivative equals to?
Yeah. Because remember, I subtracted 10 over and made that part of my new function.
So it'd be like F apostrophe parentheses add x equals 10.
That's essentially what I'm graphing.
Okay.
Now, the other way to do it, which is option 1, would be to do this. Okay, instead of doing that second derivative like I did it, watch this. I could just graph the derivative curve, which looks totally different. You can't even see it. And then I could graph y equals 10. And then I could change my window, right? Go to window settings and go up to where I can see that happening. Look, and there I can see where that's the actual derivative curve. Where it crosses 10 is there and there. And guess what I get when I find those intersection points? Well, it's going to give you y values too, which I don't want, but the x values would be the same. Now, why don't I do it this way? It forces me to change my window and go find where they crossed. You with me? Did I have to change my window the first way? No, because I was looking for the x-axis, where it crosses the x-axis. So I like that option too. Move everything to one side and graph one equation and find out where those x-intercepts are. That to me is better than graph 10 as an equation and the derivative as equation and see where they're equal. This one makes more sense. But what if it was equal at some crazy other thing? Then I got to keep moving my window up until I can see it. But look, notice this. Menu, analyze the graph, intersection. And look, if I go, which graph is graph 1? Or which graphs do you want? I want to intersect that one right there with that one right there. And it says lower bound. I'm clicking. Now watch what happens as I go through the upper bound. Look what it gave me. This time it gave me a point, didn't it? And the y value is at 10. Well, I don't need the 10, do I? I just want the x value. 1.155, same x value. And as I open it up further, the other point, 2.37510, same x value. So I like just moving it over. I can do it with one equation. It's less button pushes. I don't have to grab the two equations that work. Are y'all kind of getting the idea? but you're going to be doing this all the time with calculus. All right, so I'm going to escape out of this, and I'm moving on to that next question. All right, look at this next one. Determine where the function is decreasing on the interval. Now,
Where's it called yet?
there you go. All right, check it out, guys. Just locked into the moment. Dang
The
it.
math was so good. The math was honestly pretty good.
Never stopped recording my last week.
Thank you.